This is the video review for A Lesson in Conversions. It was created and narrated by 2015 Books Fellow Sean Krupa and uses original material and accompanies the lesson plan created by previous Books Fellow Andrew Lucas. This video and accompanying lesson plan are part of Ohio University's Boat of Knowledge in the Science Classroom, funded by the National Science Foundation. In this video, we'll review the difference between the standard and metric systems of measurement. We'll also cover the prefixes used in the metric system. Next, we'll look at strategies for converting units, and we'll conclude with a few examples. The chart on the right lists several types of measurements in the metric and standard systems. You should be familiar with many of these. In the standard system, units have mostly historical definitions. This means they can change and have changed in the past. Metric units have scientific definitions, however. This means they're absolute and unchangeable. Currently, the countries using the standard system are the United States, Liberia, and Myanmar, while everyone else uses the metric system. Now let's look at an example of how a unit is defined. In the standard system, the unit of length is the foot. The original definition for the foot was the average length of 16 random people's left foot. Today, it has an absolute definition based upon the meter. Speaking of the meter, let's look at how the metric system defines its unit of length. 1 meter is the distance traveled by a light wave in a vacuum for 299,792,458th of a second. Why this fraction? It's based off the speed of light, which can be measured precisely. The speed of light travels 299,792,458 meters in 1 second. Therefore, we arrive at the fraction of a second needed for light to travel exactly 1 meter. Now let's look at the prefixes used in the metric system. You should be familiar with many of these. At the large end of prefixes, prefixes such as exa, peta, tera, giga, etc. are used for large quantities, such as memory storage, while small prefixes such as micro, nano, and pico describe things on the molecular or atomic level. Now let's review the strategy for converting between units. We'll use convert 35 feet into meters as an example. Begin by identifying the conversion that the problem asks you to do. In this problem, we are asked to convert 35 feet to meters. Next, you'll have to find the appropriate conversion factor. 1 meter equals 3.28084 feet, or 1 foot equals 0.3048 meters, will work. This is because they're the same conversion factor, just inverted. Start with a given quantity and end with what's desired. For this, we'll start with 35 feet and arrive at some number of meters. The conversion factor acts as an intermediate step that transfers us from the original units to the ones that's desired. It is common to see the conversion factor given as a fraction. Let's look at 1 meter equals 3.28084 feet and show that it can be written as a fraction shown below. The original quantity will get multiplied by the conversion factor. You carry the multiplication across the numerator and across the denominator, and finally end with a fraction which is reduced to your final answer. Let's see what that looks like. We start with 35 feet multiplied by our conversion factor. We see that this equals 35 feet times 1 meter in the numerator divided by 3.28084 feet in the denominator. Carrying the multiplication across in the numerator and dividing by the denominator, we get our final answer of 10.67 meters. At any time, if a unit appears in both the numerator and denominator, it gets canceled. We can see in the example above that feet appears in both the numerator and the denominator. It's good that this cancels because it's the unit we want to abandon. The only unit we're left with is meter, which is what we desire. Now let's do a few examples. The first example. Convert 2,500 kilograms to tons. You'll need the following conversion factors. 1 kilogram equals 2.20462 pounds, and 1 ton equals 2,000 pounds. Set up the problem and solve. You may pause this video now to work on this example. The answer is that 2,500 kilograms equals 2.76 tons. Let's follow the steps. First, we take 2,500 kilograms and multiply by the first conversion factor, 2.20462 pounds in 1 kilogram. Then we multiply by the second conversion factor, 1 ton equals 2,000 pounds. We see that the numerator becomes 2,500 multiplied by 2.20462 times 1, and we divide by 1 times 2,000. Again, notice how kilograms appear in both the numerator and denominator, and pounds appear in both the numerator and denominator. That means kilograms and pounds are canceled, and the only unit we're left with is the one we desire, tons. Now let's do a little bit more complicated example. Convert 65 miles per hour to meters per second. Here, you're given the following two conversion factors. 1 mile equals 1.60934 kilometers, and 1 hour equals 3,600 seconds. Set up the problem and solve it now. You may pause this video to work on the example. The answer is that 65 miles per hour equals 29.06 meters per second. Let's look at the steps. First, we take 65 miles per hour, multiplying it by the first conversion factor, 1.60934 kilometers per mile. Then, we convert kilometers into meters, based on the prefix chart listed earlier on in the video. 1,000 meters equals 1 kilometer. Finally, we multiply by the last conversion factor, 1 hour equals 3,600 seconds. We're left with a numerator of 65 times 1.60934 times 1,000 times 1, and a denominator of 1 times 1 times 1 times 3,600. Dividing the numerator by the denominator, we arrive at our answer of 29.06 meters per second. This time we have 3 units that cancel. Miles appear in both the numerator and denominator, kilometers appear in both the numerator and denominator, and hours appear in both the numerator and denominator. That means the only units that are left are meters in the numerator and seconds in the denominator, which is what we desire. At this point, you should be experts on unit conversion. You're now ready to do the rest of the lesson plan. Thanks for your attention.